Thank you very much. Good morning. Thank you for giving me the opportunity to speak about my field, my story, uh, challenges, challenges and opportunities. I'm Parry Husbands, and my area of research is parallel scientific computing. And by this, I mean we harness the power of a large number of computers working together to to solve problems in science. Areas include, climate simulation, material science, which is engineering materials to have particular properties, other areas of physics, mechanical engineering, drug discovery, epidemiology, economics, energy, the list goes on. What links all of these together, of course, is the mathematics. We can computationally solve a variety of problems uh, by reusing software for performing basic mathematical operations and solving different types of equations. And the challenge, of course, is to put these together in an efficient way. And this is, what initially drew me to the area. It's enabling technology. One famous example involved a program that started out in weapons testing, right? How it was used by the U.S. military. How seeing how objects behave when they collide at high speed. Okay, but then it got used to design safer cars because it's cheaper and more effective to simulate crashes in computers instead of building real prototypes. Ultimately, it was adapted to study how juice boxes deform, making them less likely to fail, and so impacting a product that's used by millions and millions of people. And now, a lot of the techniques that have been developed in parallel computing now find a home in machine learning and artificial intelligence. Uh, uh, but I guess I'll say a little bit more about my story. How did I start, right? Initially, I learned to code at a summer program between Form 3 and Form 4 at Mango Information Systems on Chaussee Road. I don't know if any of you remember it. And it was taught by a friend who was a few years ahead of me at school. And with this basic knowledge, I even managed to get a little job locally doing some programming tasks for business. Because I did a double major in math and computer science at the beginning of my graduate studies, I looked for a specialty that combined the two. After starting first in more theoretical computer science, I took some classes in scientific computing and started research with a professor who was incredibly supportive and incidentally continues to be a collaborator to this day. Since then, I've performed research in an academic setting in a public research lab that's owned by the US Department of Energy. But in the last, say, 10 to 15 years, I've mostly been producing software. Most first at interactive supercomputing, which was built on my PhD research in trying to make high performance computing user friendly. Then at Microsoft, and now I work at Light Matter, a company that is building a new type of computing device for artificial intelligence applications based on manipulating light instead of using silicon transistors. But in thinking about challenges to research and innovation, in addition to a lot of the topics that have already been discussed, uh, a few came to mind, and I guess these are in some sense universal. One is acquiring the skills, learning the craft, demystifying the process. Is research and innovation accessible to just a few, or is it something that many all of us can participate in? Obtaining the infrastructure for experimentation is a challenge, as well as support and getting started in the field. Compared to when I was growing up, long ago, and this was before the smartphone, and many barriers have been lowered through recent advances in telecommunications and computing. As we all know, resources for online learning have exploded, and a lot of information is just a search away. And now it's possible to access many different kinds of learning materials and gain certification in a variety of subjects. There was a famous example from a Stanford online course where the professor remarked that many of the best solutions didn't come from the Stanford students, came from people on the other side of the world. But that's only the beginning of the journey, taking the classes. Progressing as a researcher, however, takes practice and guidance, and this is still a scarce resource. And I'm very grateful to have been around, and I had the opportunity to learn from, some truly world-class practitioners, in Toronto, at MIT, and also at UC Berkeley. Maybe 15, 20 years ago, to do research in my field, one had to be associated with a major computing center, because that's where all the big computers were. The national labs and some universities. But now, we have cloud computing, and infrastructure is generally available, although cost to rent the equipment is still a challenge. Data, which is the raw material for a lot of research, is also getting to be more accessible. As an example, ImageNet, which is a freely available database of labeled images. This is a dog, this is a cat. Has really helped accelerate the field of artificial intelligence. One of the big developments in computing has been free and open source software, where designs and instructions for software programs are available to everyone. And it has made it possible not only to learn how software is constructed, but to modify, customize, and adapt to different uses. I'd also like to note that the move to more open access publication has also helped in this regard. So I think the general trend has been to democratize computer science and technology, and this has made it possible for a variety of solutions to be developed, and it's not just in developed countries. One of the points I'd like to make is that we could leapfrog the capabilities of developed countries because of how open and accessible a lot of the building blocks have become. And as an example of something that's been a really interesting project, the Aadhaar project in India that has given everybody a verifiable, biometrically validated identity, and has really been a big boon to their society and economy, because now everybody has easy access to government services, banking, credit, and other value-added services. But computing and technology is not a means onto itself. I hope that this initiative gives us the opportunity to continue to bring together and nurture interdisciplinary teams to develop locally relevant solutions. And thank you once again for the invitation to participate, and I hope I can contribute in the future in any way that I can. Thank you.